Section 7.3 in geometry, we're dealing with similar triangles. So you remember when we were dealing with congruent triangles and we had side, angle, side, angle, side, angle, we had side, side, side. Those are all shortcuts because when two angles are congruent, then that means all their sides are equal to each other and all of their angles are equal to each other. In similar triangles, they have shortcuts too. But when it says side, it doesn't mean that the sides are equal, it means that they're proportionate. That means they, remember the scale factor, they equal the same scale factor. And when they do say angle, it means the angles are congruent. So instead of figuring out if all, remember how we did last section, instead of figuring out if all of the sides are proportionate and all the angles are equal, these are shortcuts. You don't have to do all 6, you can just do any of these combinations, and if they are all true, then you can say that the triangles are similar without doing all 6. So the first one is angle, angle. So if you can find 2 congruent angles in a triangle, we can say that they're similar. Alright? So 2 congruent angles. The next one is side, angle, side. So 3 proportionate sides. So that means whatever the triangle is here, I multiply it by the same thing, even if it's a decimal that I multiply it by or a whole number, but each corresponding part is proportionate. The last one is side, angle, side. So I have 2 proportionate sides. So that means this is A and this is A times X, so A times some number. C and this is C times X, and then we have an included congruent angle. So 2 proportionate sides and 1 equal angle. Okay, 1 set of equal angles. Go ahead and do the vocabulary, write this down, and we have one example problem. So we did do, when we were doing congruent triangles and we made the triangles congruent to each other, we knew that we can start setting sides and angles equal. Well, in this case, we can set angles equal, but we can't set sides equal, but we can set them proportionate. So the whole goal is to prove triangles similar so that we can start solving for letters. In this case right here, we know that this angle and this angle equal each other because of vertical angles. So angle RQS is equal to angle TQU because they're vertical. Right? The next one here, this is parallel. So this is parallel to this. And if we count this as a transversal, what kind of angles are these? Well, those are interior angles. So angle S equals angle U because of alternate interior angles. Okay? Sorry, that's alternate interior. So just like we did when 2 angles were congruent, this is when we're trying to prove 2 angles congruent, this is an angle, right? This is an angle. And if you go back on your notes, if I can prove 2 angles are congruent, automatically I can say that triangle UQT is similar to triangle, sorry, I didn't need to write that. Triangle UQT is similar to triangle SQR. Remember, I have to write it in a way so the angles that are equal to each other are in the same place. So U is equal to S, because I wrote it here, Q is equal to Q, and T is equal to R. And the reason I can say they're similar is because of the angle-angle similarity. So 2 angles I can prove. Now, what was the point? This is not a proof. It's not telling me to prove anything, but what was the point of me proving that they're similar? Well, now that they're similar, I can find what RQ and QT is. Because I know all I have to do here is find my scale factor. So I'm gonna and then I can can create 2 proportions that are equal to each other and solve for x. Remember that cross multiplication we were doing in section 7.1, where that's where this comes in play. So what I mean is, because these are proportionate, all their sides are proportionate. So since u equals s and t equals r, I know that ut is and rs are corresponding, and I know that qt and rq are corresponding. So now I can plug it in. Ut is 10, rs is 4, over x plus 3 and 2x plus 10. See, once I find a number that I can find the scale factor than the rest, I just have to solve. This is all from 7-1. So 7-3 is me setting all of this up. Once I have this set up, I plug it in and I solve like I would a cross multiplication. 10 times 2x plus 10 equals 4 times x plus 3. So we should be able to take it from there easily. 10 times 2 is 20x. 10 times 10 plus 100. And the next one, 4 times x is 4x. And 4 times 3 is 12. So I'm going to subtract 100 from both sides. I end up with 20x equals 4x minus 88. Then I'm going to subtract 4x from both sides. I end up with 16 equals negative 88. 16x equals negative 88. So I do 88 divided by 16 is 5.5. Let me check this work real quick. I get nervous when there's a decimal. We have 2x plus 10. Oh no. It's supposed to be QT. Oh, these are supposed to be switched. I apologize. Because QT is supposed to be on top. QT is supposed to be on top. So that means QT is 2x plus 10 over x plus 3. It's very important that we put it in the right spot. So, let's try this again. So, it's supposed to be 10 times x plus 3 equals 4 times 2x plus 10. This looks better. Okay? Let's go from here. This gives me 10x. This gives me plus 30 equals 4 times 2 is 8x plus 40. So I'm going to subtract 30 from both sides. I end up with 10x equals 8x plus 10. I'm going to divide 8x from both sides. I end up with 2x equals 10. Divide by 2, x equals 5. Now the question is, am I done? Is it asking me to find x? What it's asking me is to find RQ and QT. So RQ, I just take x and I plug it in. RQ is x plus 3. So 5 plus 3, which would give me 8. QT, I'm going to plug in 5, is 2 times 5 plus 10. This is 10 plus 10, which is 20. So my two answers are 8 and 20. Sorry about that mistake. Go ahead and try page 400, number 2 and 4. 400, number 2 and 4. Now remember, you can only make these proportionates equal to each other if the triangles are similar. So check for that first to make sure you can prove that it's similar. If not, then you can't solve it and you just say there's no answer. Again, try page 400, number 2 and 5, and I'll see you in class.